Let's solve one more problem. In this problem, we wanted to find the slope and deflection at the quarter span. So I'll call this a distance E, point E at a distance 1.5 meter from A. That is what is the quarter span. So I just wanted to know what is the slope and deflection at E. That is what is at the quarter span. Now if we use method second, if you're using the method second, so we always need, in the moment area method, we always need a two referential point. So what are the two referential point we'll be taking? Obviously it's C, E and C, because you know that tangent drawn from E is 0, so it will be easy for us to calculate. So we'll always consider E and C. Now if I go with the same thing, what will happen? As per the definition, it's an area of Amoria diagram between E and C. So this is what is E. So I call this in 1.5 meter, and this is 1.5 meter between A and C. Area of Amoria diagram between E and C. So you have to calculate this part of the area. So there is no direct way to get the area equation for, once again, the Quater parabola. So what we are going to do is we'll use a concept of integration now. So that means I'll shift myself to the method one. So let's it's not that complicated. You can easily do it. So let's do it. Theta EC, that is, what is theta EC? As per the definition, theta E minus theta C. So theta C is equal to 0. So that means theta E. So which is equal to, that is theta E is equal to, if you use the integration, so it is integration M divided by EI into dx. So this is what is mx. Now integration. So what is the integration range you will give it? You're going to take a small elemental strip here. So let me write it in a small elemental strip. At a distance x from A is simply supported and A. Okay, so what is the region now? Integration region at the C point, it is varies from 0 to 3. You need a area from E to C. Integration range becomes 1.5 to 3. So you have to be very careful, because this is what is the region you will be looking at. So this region is 1.5 to 3. Now what is the mx here? The value of mx is the bending moment at any distance x from A. So that is what is x from A. What is the bending moment at a distance x from A? So how will find it out? That's the total reaction. What is the reaction here? VA. VA is this is 60 into 60 divided by 2. So that is what is the 30 kilonewton. So you have a reaction here 30. 10 into 6 divided by 2. So 30. So then what is the bending moment at any distance x? Bending moment at any distance x is reaction. That is, if you want, I'll write it in that fashion only. VA into x minus W into x square by 2. So what is VA here? VA is 30 into x minus W. W is 10. 10 by 2 is 5. So I'll write 5x square. So this is what is mx. This is what is the mx value. Now substitute the same thing over here. So what will happen? Theta E is equal to integration 1.5 to 3. Then substitute 30 x minus 5x square divided by EI into dx. Now use the integration. You solve for this. If you solve, then you will get it 61.875 by EI. So this is what I got, slope at E. Now we need to find out the deflection. So we need to find out the deflection at E. So how to find the deflection at E? So we need a two referential point. So I'll write down deflection deflection at E. So how we'll find the deflection at E? We need a two referential point, as we discussed. What are the two referential point? This is what is E. This is E, E point. So two referential point are E and C. No change. E and C is the two referential point. Now, how will you do it? You need to draw a tangent from C. Now, what is the definition says? Now, it's very, very important how you do it now. You want the deflection at E. So, this is what is the deflection at E. I call it the E dash. At the point of elastic curve, location of E, I call it as E dash. Now, I want E dash. So, if you use the two referential point, E and C, now how will you get it? We'll say if you use moment of Morier diagram between E and C, about C, you know what you're going to measure? You're drawing the tangent from E and you're measuring deflection here. This is what you're getting. This is not you're looking for, right? Because if you take the moment of Morier diagram, E and C, about C, you're drawn the tangent from E dash, and you're measuring at this point C. So this is not the deflection you're looking for. Now suppose if you do it in a reverse manner, moment of Morier diagram between E and C, about E. So what will happen? You're getting this small region. Once again, so I call it as this point is E double dash. You're getting E double dash. So your problem is not solved. That means you have to do it in direct manner. That is, you'll be using the maximum deflection here. That means you know this point of E dash. So suppose I want to find a deflection now. What is the deflection? E dash is my deflection at C. That is what is delta E, which is equal to, how we'll find it out? E double dash, that is what is the whole deflection, that is you already calculated as the delta C, minus E dash E double dash, minus E dash E double dash. That is what you're going to do is moment of Morier diagram between E and C about E. So you get this tiny part, a small part, so you can get it. Now, so what is the answer? Delta E is equal to, you can write delta E is equal to E double dash. That is, you already calculated delta C minus E dash E double dash. Now first find E dash E double dash. That is what is moment of Morier diagram between E and C about E. So find it out. How will find it out? We'll use as I told you, we'll be using the second method. That is a method of we'll be using the first method. That is a method of integration. So if you use a method of integration, so ranges, you know that now, range is 1.5 to 3. So mx by ei into x into dx. Now what is the value of mx here? Mx, there is no change, it's the previous one. Mx is equal to 30x minus 5x squared. And what is the value of x here? Well, the value of x, let me explain by redrawing this diagram once again. So how is it? So this is the parabola and this is the center part, 3 meter. Okay, so and this is the region where I'm looking at 1.5 meter. So if you take a strip here, the strip distance is dx. This is at a distance x from A. So where you want to seek the moment here, you have to seek the moment at E. So what is the value of x here, bending moment at moment about E. What's the value of X here? Here X stands for, then you can make it out from the diagram if you can understand. So you can I'll put it here. The value of X here, what is the value of X becomes? It is X minus 1.5. The value of X is X minus 1.5, because you have to know this distance, moment about E. So this is a strip, this is what is the distance. This distance is total X minus 1.5, that is X minus 1.5 here. Okay, so this is what is the integration. So substitute everything here. Now let's substitute the values here. So which is equal to integration. So 1.5 to 3, mx is 30, x minus 5x squared whole divided by EI into x is x minus 1.5 dx. Now if you solve this, if I solve this, you will get 48.516 by EI. 48.516 by EI. Now you have calculated the values of E dash, so that means you can easily find out the values of delta E. So delta E is equal to, what is the value of delta C? Delta C you already calculated, its value is 168.75 by EI. So minus this value E dash, so that is 48.516 by EI, so which is equal to you will get 120.234 by EI.